Alright students, this video is going to go over section 1.6 in Math 2. The topic is exponential functions, and it's actually one of my favorites. A couple things though before we go over that. This is technically the student journal, and you have this little icon here. If you didn't notice this, if you click here, it'll bring this up. This is what the actual student journal looks like. It's exactly the same, but it gives you room to write the table values and show your work. It also has the graphs pre-printed, but if you don't have a student journal yet, all the information is in the Big Ideas textbook, and you can also just write it out by hand. Okay, so don't worry if you don't have this already pre-printed. Like I said, you can click it out and you'll get to here, and you can pre-print this, or just write everything by hand. Alright, one other thing I did want to show you that is a nice little feature. If you click on the any of the text.
What are some of the characteristics of the graph of an exponential function?
So the book will read to you, and that's kind of nice. Alright, so we're going to go through these. These are exponential functions, and the question is asking a little bit whether they're, they want you to match them. Now, how are you going to do this? Well, once we know a little bit more about these, it's going to be pretty easy to do. So we're going to focus on how to distinguish between these. I'm going to make a table of values, so I'm going to switch to my graph for my, we'll switch to my notebook. Okay, in my notebook, I already made the table values. These are the three functions they had. I'm going to go over the whole number examples, then we'll get to the fraction examples. Let's take a look at this. I'm going to leave some space here. Let's say I started my table with 0, 1, 2, 3. Okay? And I'm not going to write out the whole thing. And if you have a calculator, this will help. But we'll review it a little bit. So if you don't know 4 to the different powers, having a calculator will get you through those. But with 2, I think we know. 2 to the 0 power should be 2 to the 0 would be 1. 2 to the 1 would be 2. 2 to the 2 is 2 times 2 is 4. And 2 to the third is 8. Okay, so this would be 2 to the 1, 2 to the 2, 2 to the third. Okay, so don't worry about the fact that it's f of x. If you want, you can call that y. Okay, like I said, it's fancy notation. If you want to think about it, it's funcy x. It's funcy x. Now, let's establish this pattern. You notice I only did positive numbers on the table values, and that's good, but really to get a complete table of values, you will need some negatives. Now, if you've forgotten negative exponents, let's go through this one more time. Take a look how this is going. Going down is going times 2, times 2, times 2. But going up is going divided by 2, divided by 2, divided by 2, divided by 2. So if we went up one more, it's 1/2. Then divide that by 2 is 1/4. So that's what we want to see here, is this type of growth. Okay. The other thing I want to emphasize here is anytime it's multiplying like this, that's exponential growth. Okay. What's happening? Or sorry, if it's getting bigger, that's growth. It could also be exponential decay. But if it does have a multiplier, times 2, times 2, times 2, times 2, times 2, times 2, that's exponential growth. Okay. And when we graph this, we're going to see the difference. Okay. So go ahead and take a second, and you can fill in the tables for 3 to the x and 4 to the x. And then we'll compare the graphs. Okay, so I've filled in my table for 3s. Now look, take a look. Between 2 to the x and 3 to the x, not much difference. But for the final values, 8 and 27, our graph is going to be way, way bigger here already. 27 is going to be way off our graph. Okay, and you'll see a similar thing happening with 4s. It starts out pretty small. Okay, so 4 to the 0 is 1, but then you get 4, then you get 16, and pretty soon you get 64. So 64 again will be off the graph, but don't worry about that. That's the main idea is, wow, this thing's increasing fast. That's exponential growth. Alright. And again, it does have a calculator if you want. It does help to have a calculator if you want to check your numbers there. Now, I'm going to go ahead and set up the graphs, and for me, for our notes, I'm going to put all 3 graphs on one. I wouldn't usually do that, but there's a reason why I'm going to do that. So, if you have graph paper, that's good. If not, I'm just going to go ahead and use a ruler and make a really straight graph. Alright, I set up my graph now. A couple things. If you have graph paper, that helps. I did not, so I need to make sure the spacing here is very consistent, so I went ahead and used a ruler. I did the same thing on the top. That's why you'll notice on the y-axis, and that's why you'll notice it does not match up perfectly. that's totally okay, but they are spaced evenly, okay? So what I meant, it doesn't match perfectly with the lines on the notebook paper, but it does match spacing evenly. That's very, very important for your graph to look proper, okay? Because if it doesn't look proper, if it's not properly done to scale, you won't see what we're really supposed to see here. And that's the difference between 2, 3, and 4. Okay. The other thing that really helps is if you have different colors. So I'm going to use purple for the first one, and then we'll see what other colors I can find. -2 and then 1/4. It goes over -2 and then up a fourth, so very, very low. Just very, very low. -1 was 1/2. 0 and 1. 1 and 2. 2 and 4. And 3, 8 would already be up, way up over here somewhere. Okay. So go ahead and graph those points very accurately. 0, 1, 1, 2, 2, 4. And again, with graph paper, the graph paper would have them all spaced out evenly, and that's very, very important for the look of this. Okay. Go ahead and I'm going to pause it, and then I'm going to connect them with a curve. So a couple things about this exponential curve. It goes really, 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 really steep. It looks to me like a skateboard ramp. Okay. It looks like a skateboard ramp. It starts very, very flat at the bottom, and it transitions and then goes almost towards vertical. Almost towards vertical. That's pretty steep. Okay, and that's the 2 to the x. Okay, and so you can label 2 to the x right next to it. They labeled all of ours f of x, but you could also write f of x here. But then, since they labeled all of them, that wouldn't be helpful. Go ahead and take a minute, pause the video, and then go ahead and graph 3 to the x, and let's see how that differs. And again, if you have a different color, that would really help. Okay, take a look. Here's in green we have the 3 to the x, and again here's the difference. On this one you were at 1, 2. This one was already at 3. Doesn't seem like much difference here, but by the next one, this one was at 4, and 3 to the x was all the way at 9. So the difference there jumped already very, very significantly. When we're at 8 here, the other one's at 27. It's way, way, way off the graph. All right. So take a second and go ahead and graph the final points for the 4 to the x. Now take a look. You'll see a big difference between here. All of them, by the way, all of them go through 0, 1. Okay, let's take a look at that. That's an important characteristic for all of them. But 4 to the x, you'll notice, is steeper than the green line, which is 3 to the x, and that's steeper than the other line, which is 2 to the x. So purple, green, and orange, they're definitely changing in steepness here. Okay, and so that's the difference between them. The bigger the number in front, the steeper the graph. However, and again, this is key, they all pass through here, and that's kind of interesting. And that's because 2 to the 0 would go through 1, 3 to the 0 would go through 1, and 4 to the 0 would all go through 1. Okay, so if the book asks you, what do all of these things have in common? Well, it's hard to tell, but if you graph them all on the same graph, they'll all go through the same point. Now, if you look back in the book, back in their exercises, they wanted you to do just matching. Okay, so hopefully from here you could tell some of these definitely don't look right. Ours was definitely increasing, but to tell the difference between like A and C, you have to look at a very specific point, like right there. Or at 1, this is 1, 4, this was 1, 2. So look for those differences. Okay? Even though they all did 4 separate graphs, since we have the table of values, that will definitely make the difference. In the second part of the video, I'll actually use Desmos to make our table of values a little bit easier. So right now, let's go through the fraction ones. 1/2 to the x, 1/3 to the x, and 1/4 to the x. So I'm going to switch back to our notebook. And 1/2 to the x, 1/3 to the x, 1/4 to the x. Now, don't worry about the fact that these have f of x, and don't worry about the fact that they have fractions. We can handle fractions, and we can handle them either by doing it by hand or with a calculator. But either way, what you're going to want to need, what you're going to want to do is do a table of values here. Now, we have two difficult things going on here. The negatives and we have fractions. So if it helps, let's start with the zeros and go through the positives, and we'll work back to the negatives and see how that makes sense. Again, 0 exponent, 1/2 to the 0 power would be 1. 1/2 to the 1 power is 1/2. Now, 1/2 squared, don't worry if you don't know fractions very well. All this means is 1/2 times 1/2, because squared means write it twice. And when you're multiplying fractions, you multiply across the top. 1 times 1 is 1, and across the bottom, 2 times 2 is 4. And so for 3, 1/2 to the third would be 1/2 times 1/2 times 1/2. And 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. All right. So as we go to bigger numbers here, we're actually getting smaller fractions. 1/8 is smaller than 1/4, which is smaller than 1/2, which is smaller than 1. So it's actually getting smaller. All right. Whereas the other graph was actually getting bigger and bigger, which is kind of weird. Let's work our way back up the chain. If you don't know negative exponents very well, let's practice them. The rule with the negative usually says you make it upside down. Okay? It's usually written something like this. X to the negative 1 is 1 over x. Well, what if you already have a fraction inside? Well then, just like this, remember we flipped it 1 over x? Well, if you flip 1/2, it becomes 2 over 1. To the positive 1. So we flip the fraction, and the exponent changes. The 2 over 1 is just 2, to the 1 power is just 2. For the negative 2, 1/2 to the negative 2 power would really be flip the fraction inside and change the exponent to positive. That would really be 2 times 2, which would be 4. For the negative 3 exponent, we get 1 over 2 to the negative third power becomes 2 over 1 to the third, which is 8. Because 2 times 2 times 2. 2 over 1 is just 2, and to the third power, it would be 8. So, let me rewrite our table here because I made it a little bit messy. There's our table. It went from a little bit messy. Here's the final numbers you want to actually graph. So, take a second, let's make a straight graph, and let's graph it. And once you're finished, your graph should look something like that. So what happens here is, this is sort of in reverse, okay? This one actually looks like half of a skateboard ramp, and it starts off really flat on this side, and then shoots towards infinity this side. Alright, so that's the 1/2 to the x. So it's flip-flopped from the other one. If you look back to this side, there we go. It was flat and shot up, whereas this one was flat and shot up. So that's the difference between the two. Hopefully the table of values makes sense and helps you out. And for 1/3, it's the same rule. Follow this table, but instead of multiples of 2, you'll have multiples of 3. Alright, this video is almost over. In the next video, if you come back, we'll go through the same numbers, but on Desmos, and show you how the graphing calculator can make it a lot faster for you to do table of values. Thanks for watching.